Hello, good morning to all students. Myself Dr. Sindar Chaudhary. Today I will teach you error and evaluation. Error and evaluation measurements invariably involve errors and uncertainties. Only a few of these are due to mistake on the part of the experimenter. More commonly, errors are caused by faculty calibration or standardization or random variation and uncertainties in results. Frequently, calibration and standardization and analysis of known samples can sometimes be used to lessen all but the random errors and uncertainties in the limit. However, measurement error are an inherent part of the quantized world in which we live. Because of this, it is impossible to perform a chemical analysis that is only free from errors or uncertainties. One can only hope to minimize error and estimate their size with acceptable accuracy. In this lecture, I will teach you mean, median, precision and accuracy. What is mean? The definition of mean is an average of n numbers computed by adding some function of the numbers and dividing by some function of n. The central tendency of a set of measurement result is typically found by calculating the arithmetic mean x bar. It is denoted by arithmetic variables denoted by x, and less commonly the median or geometric mean. You can see in the slide, we can represent in the mathematical expression here. If x1, x2, x3 and so on xn are n value of variable x, then the arithmetic mean are simply the mean of these value is denoted by x bar and is defined as an expression. And here the symbol summation for n and I is equal to 1. Xi denote the sum of x1, x2, x3 and so on. In other words, the arithmetic mean of a set of observation is equal to the sum divided by the total number of observations. For example, if the height of 5 persons are 155, 142, 151, 140 and 157 centimeter respectively, so what is the mean height of the first 5 persons? So we can apply the above mentioned formula of mean and we can calculate the value of mean height. So here we will be calculate the value of 5 person. So the sum of these heights are 745 and the number of n is 5. It will be so we divide 745 from 5 and we can get the value of mean height x bar is equal to 149 centimeter. In other examples, if the mean of 6, 4, 7 p and is the mean value is 8, and then find the value of p. So in the the solution of this problem, we know that the x bar value is 8 and summation value of all these mathematical variables is 27 plus p. So cross multiplication of 8 to 5 is value is 40 and we can find out the value of p. So the next content is what is median. The median is the middle value between the smallest and largest of a set of numbers. The median of a set of numbers is the number which appears in the center of a set of numbers when they are placed in a numerical orders. The median is the middle result when replicate data are arranged according to increasing or decreasing values. For an odd number of results, the median can be evaluated directly. For an even number, the mean of the middle pair is used. So that find the median of the above test scores. First sort them in increasing numerical order. You can see in the slide 65, 63, 65, 73, 74, 83, 83 and 88, 92, 94, 95. These are the number in increasing numerical order, and find the number in the middle of these sequences. So this number will be the median. The median test score is in the increasing numerical order is 83. This worked out nice because there were an odd number of test score. If the number of tests were even, there would be 2 test score in the middle of the set. The median would be the mean of the both numbers. Let's take the sum test score but remove the low one. So that now we have 8 test score. The sequence will be becomes 73, 74, 83, 83, 88, 92, 94 and 95. So according to this increasing order number series, first we find out the middle number increasing in number is 83, and if the decreasing order number series is this number is 88, and here the firstly we together both number and the sum of this number is 171, and it will be divided by 2 because the n number in this case is 2, so it will be divided by 2, and then we get the new test score is 85.5. The median of a series of number is the number that appears in the middle of the list when arranged from smallest to largest. For a list with an odd number of members, the way to find the middle number is to take the number of members and add 1. So now then divided that value by 2. In our case there are 9 numbers in this series, so 9 plus 1 because 9 is an odd number and we will add 1, then we get 10, and its half value of 10 is 5. So that the fifth number in the series is the median or 14. If the number of member of the series was even, the average of the 2 middle numbers would be the median. For example, find the median of the following values. You can see in the slide the mathematical values are 37, 31, 42, 43, 46, 25, 39, 45, 32, and here the number of n value is 9. 9 is a odd number. So firstly we arrange all of these mathematical values in ascending order. The order of ascending of these mathematical values are 25, 31, 32, 37, 39, 42, 43, 45, 46. We know the number of observation n is 9 and it is odd, so that the median value is, applying the formula, if the odd number we will be 1 number add in this n number, so that, and the after the 1 number of addition its value is 10, and it will be, and its half value is 5, so that our observation is 5th. So in ascending order series the 5th number is 39. Now the next content is precision. Precision is defined as the extent to which results agree with one another. In other words, it is a measure of consistency and is usually evaluated in terms of the range or spread of results. Practically, this means that precision is inherently related to the standard deviation of the repeated measurements. In analytical chemistry, the term of numerical value is defined as the degree of arrangement between it and other values. obtained under the some condition. In other words, we can say that the precision is used to describe the responsibilities of the results. Accuracy without precision is impossible. It should be noted that a high degree of precision does not imply accuracy. Precision describes the reproducibility of measurements. In other words, we can say that the closeness of results that have been obtained in exactly the same way. Generally, the precision of a measurement is readily determined by simply repeating the measurement on replicate samples. There are some terms widely used to describe the precision of a set of replicate data via average deviation. The average deviation of the measurement of a set is the mean of the difference of the individual measurements without regard to sign. Standard deviation is average deviation is of the measurements of a set of the mean of the difference of the individual measurement. So we can express in form of mathematical terms. You can see in the slide, in this equation, in this representation of average deviation, here x bar the mean of measurements. We can I have also explained in the first content what is the mean and how it is calculated. Here xi is the individual measurements and n is the number of measurements. For example, if we want to find out the average deviation and the relative deviation of the following sets of analytical results, here if we have three analytical results like 16.719, 16.759 and 17.120. So we apply the above mentioned formula and we can calculate the value of xi is 50.58 and the number of n is 3. So that now mean of measurement we will be apply and we can calculate the value of x bar is 16.86. Further, we have the value of xi and we can find out the value of xi minus x bar. So that we have the value of x bar mentioned in the above slide 16.86. So that it will be subtract from the value of xi. So now total xi minus x bar value is 0.52 after the addition. So this value is called a relative deviation. And we can calculate the relative deviation because we have the number of the total number of xi minus x bar is 0.52 and we know the number of n is 3. When the divided by 3 we get absolute value of relative deviation is 0.17 gram and the relative deviation is d upon x bar and it will be multiplied by 100 and we can calculate the value of relative deviation around 100 parts per thousand. Now what is standard deviation? Standard deviation denoted by sigma of an infinite sets of experimental data is theoretically the square root of the squares of the difference between the individual measured values xi and the mean of the infinite number of measurements, which is noted by mu. You can see, and these conditions we can write mathematically in terms of mu. Sigma is equal to under root summation of xi minus mu and its oblique n. In the above equation and having value infinite and we must calculate the individual deviation from the mean of limited number of measurements and x bar, in which it is anticipated that x bar having a infinite number of measurements value, and for the set of n measurements and independently variable deviation from some references number, if the n minus 1 deviation are adequate, the nth the estimated standard deviation as infinite sets of experimental data more nearly approximate sigma if the number of degrees of freedom is substituted for n. So we can get the value of standard deviation, and it will be shown in the slide. For example, find a standard deviation of given mathematical variables. First, work out the mean value. The mean value of this mathematical variable is 10.222. Now subtract the mean individually from each of the numbers, given the square the results. After the applying formula of standard deviation, this is equivalently to the x whole square step. Then x refers to the value given in the questions. You can see in the table. Now add up these results in the formula. Sigma is 139.55. It will be divided by number of the n. Here n is the number of values, so in this case we have the number of n values is 9. This gave us the 15.51. When we divide 139.55 by 9, we get the answer 15.51. And finally square root of this 15.51 is 3.94. So we can find out the standard deviation. Accuracy. Accuracy is defined as the closeness of a result to the true value. This can be applied to a single measurement but is more commonly applied to the mean value of several repeated measurements or replicates. The accuracy of a determination may be defined as the concordance or a agreement between it and the true or most probable value. It follows, therefore, that systematic error causes a constant error and thus affect the accuracy of a result. Since no measurement is completely accurate, the true value is never known except within certain limits. The accuracy of value is therefore never known except within those limits. The true values can be approached but never attained. You remember it. Thus, accurate results are assumed to be those measured values which have been obtained by skilled scientists using instruments of the best quality. But accuracy indicates the closeness to the measurement to the true or accepted value and is expressed by the error. Accuracy is often more difficult to determine because true value is usually unknown, and accuracy is expressed in terms of either absolute error or relative error. Absolute error, the difference between the true value and the measured value with regard to the sign, is known as absolute error. The absolute error E is the measurement of a quantity x which is given by the equation. You can see in the equation the E is equal to xi minus xt, where xt is the true or accepted value of quantity and xi is represented individual value of x making up the set of n replicate measurement. For example, there are two numerical values, that is 4.431 and 4.410. If first value is regarded as a true value and the second value regarded to the absolute error of the value, so we will put these values in the above mentioned formula and we can find out the absolute error. And what is relative error? The absolute or mean error expressed as a percentage of the true value is known as the relative error. The relative error can be expressed in the parts per thousands, and it is denoted by ER, so that the representation of mathematicals of relative error is this: xi minus x2 and divided by xi and multiply by 100%. For example, we can understand the relative error from the given example. The relative error in above example is 0.021. If it will be divided by the value of xi, which is 4.431, and the percentage of 100 is 1000, so we can obtain the relative error and find out the value of relative error. In this case, the relative error is 4.772 parts per thousand. You can consider the study of error and evaluation I've mentioned in the reference in the slide for your further studies. Methods of chemical analysis, and you can consider modern analytical chemistry, and you can also go with the mentioned websites, and you can for your further study. Thank you so much.